to share our idea in presence in this platform. We are really thankful to all of you, sir. And with your humble permission, I'm starting my presentation, sir. Please. My screen is visible, I believe, sir.
Yes, yes, we can see it.
Thank you, sir. Thank you. So nice of you. Uh, uh, this is my our a very small effort to a sustainable world, to uh, achieve a sustainable world. The risk reduction of marine oil spill using cluster of fruit pellets. And I'm representing Jadavpur University, Kolkata. Kolkata is the eastern part of India, and nowadays a huge rainfall is going on, almost flood-like situation. In front of my university is almost knee-deep water. Still, I'm here to present myself. Thanking you, sir. Monsoon is very nowadays is very. So this is my small mm, whatever I have done in my life. I have almost 20 years experience in various research in sustainability, substitute cementitious material, health assessment. Now I am serving as a assistant professor in Jadavpur University, Construction Department of Construction in Delhi. And he is my student, Deepam Shah. He is a final year student. He is very energetic, fantastic guy. Before starting our stating our this small project, I want to draw your attention that why we have thought of with this problem, why it is a very striking problem throughout the world that due to globalizations, mass transportation is going on through the world, and this e-commerce, because as you know, in if you are in Indonesia or in India, you can buy goods from USA or China directly nowadays to this lot of e-commerce site, and this e-commerce site is driving the overall global supply chain. But this supply chain definitely is easing out our overall business, but at the same time with lot of what I should say, a lot of environmental cost. Means basically this all supply chain are dependent on burning of hydrocarbon based fuel, right? So at the same time, there is a lot of offshore platforms coming on, and as a lot of hydrocarbon based fuel we are burning, so a lot of ship movements are going throughout the world, so that making higher probability of accident, means spilling of oil into the seashore or sea uh, uh, surface. So that is a very big challenge for us, for engineers, for scientists, how to mitigate that kind of problem. So that striking problem in a very small scale, we are thought of, okay, let's find out some solution so that we can reduce the risk of marine environment or marine species through some sustainable solution. That solution, that work, I'm here to present in front of you. And background and introduction of our work. 90% of the world goods are transported via sea routes. It's a published data available in the world. Apart from this, the global inter-transportation system depends on hydrocarbon-based fuels. This is true for not only sea, this is also true for aviation and land route also. Majority of modern products such cosmetics, lubricants, paints, all are other byproduct of crude oil or acrylic base, which is acrylic is also byproduct of crude oil. So crude oil dependency is a big issue nowadays. So the major extraction of this crude oil executed on the offshore platform. This inevitable dependency on the crude oil and the maritime logistics leads to a high probability of accident in maritime water. And these threats, this is really a big threat, potential threat to the oil spills into the marine environment, right? Actually, what just materialize after an accident, consequence of an accident, whenever oil spills on the sea, as everybody knows that the overall specific gravity or density of the crude oil is lighter than the water, so it floats, and due and during and dependent on the environmental condition, it spreads into the water flow and it flow over on the sea bed with the help of air, and some percentage start evaporates just after spilling, right? So this is the very initial stage, and subsequent stage I am just explaining to you how a oil is, or crude oil is basically behave just after whenever it is starting floating over the seabed. Just in my next slide, right? This is the scenario. Initially, if you see, this is the time scale is a very standard data available in any research work that we have studied, right? Initially, the just after spilling for one in a first week, it spread, then it drifts, and evaporation start just after spilling. After 1 or 2 days, dispersion starts, then emulsification, which is a very dangerous thing, because whenever it's emulsification, it affecting, or it is percolating, mixing with the water, seawater, and it is affecting the marine zooplankton, phytoplanktons, and it may subsequently affecting the other big creature or animals in the sea, which actually depended on the very small creature of phytoplankton. So these dispersions, emulsification, and sedimentation is very dangerous part. So we should be very careful that if we can take action very early time, we can reduce the uh, effect on the marine life of any sea. So from this chart, we can have a information, we can have a decision that initial action, timely action is very important for oil spray, right? So this is the thing I want to explain from this specific uh, chart. So our objective is that we should effectively dealing the oil spills, curtailment of the spreading that already have explained. We should not allow the oil to spread, because spreading is very dangerous. More or more it will spread, it will emulsify, and it will going to affect the zooplankton, phytoplankton. It will be absorbed so many of hydrocarbon, and this planktons will be encapsulated with that very thick hydrocarbon molecules, and it will die, and it may have a subsequent effect on the larger creatures who are dependent on the very tiny tiny particles of zoo and phytoplanktons, right? So our basic study was or objective of this study was to reduce the overall spills with a very sustainable and easy solution. Definitely, there is a lot of solution available in the world we have studied, but our objective is to give or to find out a very easy, sustainable solution. I will explain the solution in my next slides. So it should be very affordable. It should be very affordable, and to make it affordable, some small even fishermen can be involved to reduce the curtailment of that spilling of oil, right? So,
You have
or oil,
2 minutes. Yeah.
oil.
You have 2 minutes.
Okay, okay,
All right.
sir, please. Okay. The past work, we have seen that a lot of work was done by various scientists that various food pills can absorb oil, crude oil. So on that idea, we have materialized it in a very smaller scale. Okay, we will use, because in, as you know, directly initially, a lot of persons in this tropical region, especially in India and this tropical region, we are consuming food directly. But nowadays we are having a lot of food processing industry, and that food processing industry is basically producing byproduct of food pills. And if you can use that food pills to extract oil from the sea, that may be a very good sustainable solutions. And to visualize or to study or to materialize that solution, what we did, we prepare a very small system like this. This is the system. Uh, we This is the orange pills, and we put the orange pills in a small net, and that orange pill is floated on a small tank, and that tank is floated with thick oil, and we put that orange pills on that particular tank. And with that time, we noted that that dried orange pills are absorbing oil from that top of the surface. And that study, we just in a very small scale, we did it. And that study, this is the, see, this is the oil on a tank, and this is the orange pills, dried orange pills, which is floating on the top of the tank, and that is absorbing the oil. And that absorption is actually we taken at the time we have calculated that rate of absorption with respect of time, and this is the absorbed oil with the time, and we find it is very, see, this is the after absorption, the condition of the orange pills, dried orange pills, no? And this is the thing. So initially it is absorbing very high rate, right? And after that it is getting saturated, and result is we are getting very astonishingly encouraging. And it seems that it may be in a larger scale, it may be very working. And we believe that this concept of absorbing this crude oil from sea surface or sea top with the help of orange or any food pills in a very simple system can be very effective solution to mitigate, to reduce the dispersion of the oil in a very quick and low responsive time. And it is a very easy solution. At the same time, it is a very cost-effective solution, right? So in a conclusion, initial absorption rate is so high, and we believe that may be a very good solution for future work, and we are planning to do a larger research on this particular solution method, right? And last word and last slide, in time I am trying to finish it, sir, that finally we can state that in conclusion that our research project is a very green and sustainable approach, because we are encouraging industrial ecology. Industrial ecology means one byproduct of the one industry using in a different industry. So we are encouraging the industrial ecology. So one byproduct we are using in a different industry to make our earth more greener and more sustainable world. Thank you, sir. Thank you. And I have tried it to finish it in 10 minutes. Thank you, sir.
All
So
right.
nice.
Thank you. Thank you very much. That's a very unique and very interesting solution. Yeah, with the how to absorb the oil spills from the ship. Okay, for the all audience, if you have any question, just raise your hand and I will give the opportunity to you to ask directly to Dr.
Dipesh Majumdar.
Dipesh Majumdar.
Yes.
Dr. Majumdar. Is there any question?
Thank you. Thank you.
Yes. Is there any question from all audience? It seems that your explanation is quite clear, yeah. So that's why there's no questions.
Thank you, sir. Thank you. No problem, sir. Thank you. So nice of you.
Yeah.
So
all
nice.
right. Okay.
Okay. I'm stop sharing, sir. I'm stop sharing.
Yes, please.
Okay. Thank you, sir.
All right. Thank you very much.
Thank you, all of you. Thank you, all of you. Thank you.
Thank you very much, Dr. Majumdar, with the title of your presentation, Risk Reduction of Marine Oil Spill Using Cluster of Fruit Peels Pellets. Now we are going to the next session. Is from Professor Missy Gozan. You want to presenting yourself or just using a video that?
Yeah, it's already in the video.
Okay.
It's in the video.
Okay, so I will play the video, yeah?
Thank you very much.
All right. Okay, for the next session will be Professor Mr. Gozan with the title of the presentation is What Should We Do with the Oil Palm Solid Waste? Now we can watch the video that Professor Gozan is already giving to me.
Good afternoon, ladies and gentlemen. Thank you, Mr. Moderator, for your allowing me to introduce our research. Please allow me to share my PowerPoint. This morning, I have already talked about how to make a sulfura out of oil palm and fruit plants. But actually, you can do also the valorization or increasing the value of chemical of solid waste to other high added value chemicals. And today, our research group has been doing a lot of research and also studies from researchers to do this valorization. This is my research laboratory. So we know that we can have about 1 to 1 every 1 kilogram of CPO, we can get 1 kilogram of EFD or food tons. This is very a lot in Indonesia. So we know that in this point that we have about 70 billion ton this year already. So actually we have not only anti-fruit plants, but we have also have different type of solid waste here. So you can see it here. So different anti-fruit plants, different solid waste here. So we have different also composition of cellulose and hemicellulose, lignin, and also ash. But you can see here that cellulose is quite high, more than a third of it in AFP, and especially in the stem. And also the lignin is very high in PKS, which is why it's very, very difficult to use. So for those of you who are not familiar with the terms, I can inform you that EFD or anti-fruit plants is a byproduct of sterilization and mailing of fresh fruit plants in the processing plant. In the processing plant of CPO, there are also some other byproducts such as from the extracting leaf oil and sparing leaf. This is the basic fiber, and also palm kernel cell is a byproduct of processing oil palm kernels. While in the plantation itself, there are also already some byproducts such as prawn, which contain a lot of sugars, and also you can use it as a solid waste as well as also SAM, as we explained before, logging of palm trees. And there's also, of course, the oil, the liquid or aqueous phase of waste. which is we call it PO foaming. It is a liquid byproduct of sterilization process and ion extraction. So how are we going to do? What should we do with this solid waste of oil palm biomass? We can do the physical and chemical processes, or sometimes we can call it or categorize it as a thermochemical conversion. We can make activated carbons. This is very useful for the water treatment and also for other purposes. We can simply use the pyrolysis or acid biomass production followed by carbonization. Especially we use the temperature treatment here, the heating treatment here. While we can also use the result of the activated carbon can be different price. When we have a high amount of activated surface area, we can have higher price per kilogram. So this is a biofuel is a low price here, but we can use for composite. So in our country where we have 270 million people, we need the composite very much for the housing or for other purposes. We can make natural rubber biocomposite, polybutyren or any other polymer biocomposite with different kind of treatment and also with especially with methyl and butyl methacrylate. And also here we can make a graph polymer, which is very high, relatively high yield materials. We use butyl and methyl acrylate as monomer or and by hydrogen peroxide or ferrous ammonia sulfate. And also we can use we can produce as a nanoseed graphene, which is very dear and it can getting more demand today because it can be used for many purposes, especially in the high fine chemicals purposes. And also we can use very for the low price, for example, binders byproduct, board, and also here the demand of green color. This is very low price, but the demand is very high. So and the process is relatively not difficult. So this is something that might be like to produce very much. And also a microcrystalline cellulose is uh, very important and high demand nowadays, and also getting higher the price. This is the production is by floating into intercalorine free bleaching. It's a bit sophisticated here for by acid hydrolysis and hydrolyzed by hydrogen sulfate. So we can also use to produce other things such as ternanofibular cellulose and also aromatic compounds here. This is for many purposes such as additive and solvent, etc. So this is how we can produce many products from thermochemical conversion. Now let's move to the biological processes, which is more environmentally friendly. But of course, the chemical reaction is a bit lower. But then we can produce it for other purposes than before. For example, here we can produce butanediol. We can produce for example, here animal feed, because by using only fermentation, using different kind of even edible fungi, we can eat the product of the fungus, jamur in Indonesia we call it. This is edible. This is edible in very nice color, a white color and beautiful shape. You can eat it. You can sell it as for human, also for animal food. But for animal food, because this is comes from the solid waste, of course. So, but if we do appropriately, we can use it. We can sell it as a human food. But the animal like it very much. It has been done a lot in Malaysia and Indonesia as well. Besides, we can produce the biodiesel, bioethanol, biohydrogen, and also biomethane. Those are very important biofuel. So by using different kind of processes such as aerobic and enzymatic hydrolysis, and also fermentation, aerobic fermentation. And also we can produce compost, for example, composting and foaming. This is very which is when we add cellulose to this, and it's very good. Last but not least, we can produce polylactic acid out of lactic acid, which is good for bioplastic. Now, how could we how could we how could we decide what we would like to do? I give you two examples here. One is when we would like to make bioethanol, for example. The bioethanol price today is at the same price value as the $1 or $2 per liter. This means that when we burn it for firing of the boiler, for example, we can save $1 to $2 for buying any kind of fuel instead of using it. But when we would like to make a bioethanol with the same price, this is not interesting because the processing into bioethanol might not be very profitable because the same price while we are burning. So what for we are making bioethanol? Make more effort, but the same result. So if we turn it into hand sanitizer of our bioethanol, then it can be very interesting because the price is $10 per liter, which can give you a positive net present value and give you more than $100,000, indicating that the plant is economically viable. Another example is when you can produce nitrocellulose, for example, this can give NPV very high. Of course, the capital expenditure is also higher. Then many considerations are related, especially economic, environmental, to choose wisely whether product to be developed. So in conclusion, I can say that the high cellulose and hemicellulose content in oil palm solids can be converted into various chemical, biochemical, and biochemical products, such as biomaterials, fuel, animal, feed, catalysts, and other high-quality substances. A series of treatment, physical, chemical, or biological processes are required to produce higher value products. The strategies of the technologies determine the cost and quality of the products. And nevertheless, the use of oil palm biomass for various products has opened alternative solutions to environmental problems. And the development of the bio-oil palm biomass refinery is expected to increase the sustainability and profitability of the oil industry. Thank you very much for your attention.
All right. That's the presentation from Professor Gozan. So is there any questions regarding Professor Gozan's presentation? Please raise your hand and then I will give you an opportunity to ask question directly to Professor Gozan. Is there any? It seems there's no one. Or Professor Gozan wants to add something? No?
Just sorry that the title of the presentation was not correct, but the insight is okay. It's not correct. I have modified I forgot to modify the title. Okay, I just want to say that before we go to choose any kind of process that we would like to do with the solid waste or any kind of waste to make a high value added, we have to be careful. We have to calculate the economical, the price, not only the price, but also the process cost and everything. So, and also the difficulties, the availabilities of the reactants, etc. in our place, so in the location. So those are very important things. Besides the risk or the safety factors of our process. That's all I would like to say. Thank you.
All right. Thank you, Professor Gozan. And let me know if there's any question before we let the next session. It seems that everything is clear. Okay, thank you very much, Professor Gozan. Thank you very much. All right then. Now we are going to the third presenter is Alexandra Budilovskaya and Yu Shao, with the title of the presentation is Ecological Design Ideas of Large-Scale Public Buildings, a case study of greenhouses in Russian botanical garden. Are you with us, Alexandra Budilovskaya or Yu Shao? Let me know if you are here for Alexandra Budilovskaya and Yu Shao. No, they are not in, I think. Well, while we are waiting for them, I think we can go through the fourth presenter, with Adel Ahmed, Walid Said, Ahmed Asran, and Ibrahim Nusayer. With the title of the presentation is Critical Obstacles to the Adoption of Green Construction Technology, the Case of Qatar. Are you there, Adel Ahmed or Walid Said or Ahmed Asran and Ibrahim Nusayer? No. Yeah, at least there are fourth participant is not coming here today. But it's okay. I will call them later. And then we go through the number 5. The presenter number 5 is Yusuf Kasim, Hussein Chamur, Gokhan Burhe, Adifaho Frene Nesimbufe. I'm sorry if I'm mistaken. And El Hamam Am Sharfi, with the title of the presentation, the Techno-Economic Viability Analysis of Fixed Tilt and Two-Axis Tracking Grid-Connected Residential Rooftop Photovoltaic Power System for Northern part of Iraq. Are you there, Yusuf Kasim?
Yes, sir.
All right.
Yes, sir, I am here.
Are you Yusuf Kasim, right?
I'm the presenter, El Hamam Sharfi, the last name.
The last name, Yusuf
Yes, sir.
Abdul Aisha. Okay.
Okay.
For Yusuf Abdul Aisha, the screen is yours now. That's only
Okay.
like 10 minutes.
If
Yeah?
you don't mind, I'm going. Okay. If you don't mind, I'm going to be using 2 devices, one for the sharing of screen and the other for my voice.
Oh, yes, please.
Okay. Yes. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. I am going to be talking about the, as the respected moderator mentioned, the techno-economic viability and analysis of fixed tilt and two-axis tracking rigs. So this is basically a comparison between single axis and double axis or two-axis photovoltaic systems. The contents of the presentation is going to be, of course, the introduction, the aim of the study, and then after that, we're going to discuss the material and methods used in this presentation and the results we obtained from them. And of course, we're going to conclude. First, we go into the introduction. The energy sector in the is the most prominent of the economic crisis and the environmental disaster in most developing countries. This sector is the biggest waste and the primary cause of budget deficits and debt ballooning. In addition to being a primary cause of air pollution and related deaths. Moreover, the electricity crisis have been increased in many Arab countries due to the growth of population, rise in living standards, of course, and in industry sectors, which has led to an increase in energy demand and the increased electricity cost associated with fossil fuel based electrical energy production. The electricity crisis is not new in most developing countries, particularly in Iraq, and the electricity sector has suffered from decades of mismanagement, weak policies, and the absence of proper planning for the future. Also, this problem has been increased due to the abolition of old power stations that were accompanied by sabotage operations during past years. As a result, of course, the hours of power cuts for citizens increased. It ranged from 4 to 15, or maybe in some countries, it is more than 15 hours a day. The aim of this study, the findings of literature review revealed a clear lack of proposed solar PV systems for households in the northern part of Iraq. Also, according to the authors' review, no studies are evaluating the feasibility of grid-connected residential rooftops PV systems with the various sun tracking systems in the country. Therefore, the study aims to investigate the techno-economic and environmental sustainability of rooftop PV systems in 17 selected regions under different climate conditions. To achieve this, NASA databases were used to find suitable region for installing a PV system in the northern part of Iraq. Different sun tracking systems, including fixed tilt and 2-axis systems, are investigated, as we mentioned before. So this is basically a comparison between the two. Moreover, numerous economic indices have been taken into consideration as a measure of performance indicator for the proposed project. As for the material and the methods used, the following is the NASA database that is utilized to investigate the potential of solar energy in the 17 locations in the northern part of Iraq. The table you see in front of you has these 17 regions, as you can see, with the altitude and the coordinates. The highest in altitude being Tawila, and the lowest, of course, being, as you can see here in front of you, Sham Shamal, with others ranging in between 110 meters and 1483 meters. The results and discussions of this study. First of all, let us look at the characteristics of solar energy. The figure in the following. Okay. The figures in the following slide is going to illustrate the value of the annual global solar radiation, GSR, for all selected regions. It is found that the highest and the lowest value of GCR are recorded in Halabja and Galala, with a value of 1885 kilowatt hours per meter square, 1750 kilowatt hours per meter square, respectively. The value of the average temperature, atmospheric pressure, is also presented in the figure. It is observed that the maximum and minimum value of mean air temperature is obtained in Ankawa and Tawila, with a value of 20.50 and 14.37, respectively. This is the figure that we have mentioned before, and as you can see in front of you, these are the temperatures and the kilowatt hours per meter square for each and every individual region of the 17, which we've selected for the northern part of Iraq. Of course, as it is visible in front of you, the Halabja has the highest, and the rest sit in the 1800 mean. electricity generation and the capacity factor of 5 kilowatt grid connected PV system. The following table lists the slope and the azimuth angles for all the selected regions. Of course, again, these are the 17 regions selected, and this is a comparison, or this is to demonstrate the slope angle and the azimuth angle for each individual region. Performance of 5 kilowatt grid connected PV system. The financial parameters, of course, are the project life 25 years, inflation rate 2.5%, discount rate 0%, debt ratio 50%, debt interest rate 0%, debt term 20 years, and electricity export escalation rate is 5%. These are considered as input variables. In the present study, the system cost is around $5,261 US dollars, that is $7,365 for fixed tilt and 2-axis project. As you can see, it is clearly the 2-axis is clearly more expensive than the fixed tilt, but we are going to see why this is a good investment. This figure shows the 17 regions again with a comparison between the fixed tilt and the 2-axis systems input. And if you take any region, you will see that clearly the 2-axis system is much higher in generation for the kilowatt per hour. And it's not a small number. It is actually high by almost 30% more. And this goes for all of the regions, of course. And the F, of course, as I mentioned, is fixed, and the T is the 2-axis system, as it is shown below the table here. And to conclude, these are the main points for the presentation. The finding from the present study showed that the annual value of solar radiation SR for the selected region is within the range of 1750 and 1885 kilowatt hour per meter square. The percentage difference between the maximum SR and the other SR values is varied between 1.27 and 7.19%, with an average of 4.11%. It can be concluded that the amount of solar radiation can be considered the same due to the low percentage difference. Based on annual global solar radiation, the analysis indicates that the selected regions in northern Iraq have the potential for the distribution of PV power systems in residential applications. The annual energy output showed that the 5 kilowatt grid connected PV system in 17 locations, one house located in each selected region, could produce 133 megawatts per hour and 177 megawatts per hour when fixed tilt and 2 tracking systems have been used respectively. Based on the analysis, it was found that the highest energy consumption can be covered by PV systems recorded in spring and summer seasons, of course, with an average percentage ranging between 29.5% to 38.5% and 34% to almost 50% respectively. And this would conclude my presentation. Thank you very much for your attention. These are the contact details. And if you have any questions and you don't want to ask me now, you can contact me on the very last email here. Thank you very much. Terima kasih.
Terima kasih sama-sama. Well, thank you very much, Sharvi, for your presentation. Yeah. I have read your article and it's very clear and concise and satisfied with this article. But maybe all the audience here wants to ask to Sarvi regarding his presentation. Just let me know. Or raise your hand. I think just like as I told you, Sarvi, everything is clear and concise.
Thank you. Thank you, sir.
Yes. Well,
Thank
I
you, sir. Terima
think,
kasih.
yes, sama-sama. All right. Okay. We can go to the next presenter. Is Yusuf Kassim Hussein Kamu? Is it? I don't know. Maybe I'm wrong.
Yes, I'm here, sir. I'm engineer Adnan Al-Safadi, Adnan Al-Haj Uthman.
You are Hussein Kamur?
No, a third one, Adnan
Third
Al-Haj
one.
Uthman.
Adnan Al-Haj Othman.
Yeah,
All right then.
yeah, exactly.
Okay. Okay, good.
Thank you so
your
much.
presentation title is Performance Investigation of Grid Connected Photovoltaic System for Family Household, a case study in Amman, Jordan. Is that right?
Exactly, yeah.
All right. Okay. So Adnan Al-Haj Othman, the screen is yours now.
Thank you so much, sir. Did you see my screen, sir?
Yes, I saw it.
Or not?
It's clear. Yes. Go ahead.
Yes, thank you so much. Good morning from here. My name is Adnan Al-Haj Uthman. I'm from Mechanical Engineering Department at the nearest university in Nicosia, North Cyprus. Today, I will present my papers with my partners, performance investigations of grid-connected PV photovoltaic system, family, household, a case study in Amman, Jordan. Yes, first step, I will start from introduction. The second step, I will discuss material and methods. Third step, result and discussions. Fourth step, as we see, a conclusion. Introduction. All energy has been an indispensable needs for humanity. This need was met with the conventional fossil fuels until the rest passed. However, the use of fossil fuels has polluted the environment and lead to climate change due to the greenhouse gas emissions. The environmental problems readings from the increasing consumptions of the fossil fuels have led and encourage scientific researchers to search of alternative sources of energy that would to be able to generate energy and product the environment. Many scientific researchers found that renewable energy like solar and wind plays a significant role in reducing greenhouse emissions. The main objectives of the paper is investigate the feasibility of a small-scale grid-connected system that use PV technologies, monocrystalline silicon, and sunny tracking models, including fixed tilt and two-axis systems for top household and Abu Sir Amman, Jordan. Typical households were chosen for the region to establish a log before according to monthly electrical bills. A second step here, materials and methods, study area and data. Amman is all of you know, Amman is a capital city of Jordan. The area of it is estimated to be 1,680 kilometers square. It is located at a latitude of 31 degree 57 18.79 north, the longitude of 35 56 42.11 east. In general, the climate in Jordan is characterized by warm and dry summers and moderated with winters. The annual average temperature is within the range of 12 up to 15, and the highest temperature values with a region for range from 40 to 46 is according in the desert areas. And as we see all of you in the top of this page, we have two different photos. Let's talk about two locations we selected in this paper. For Jordan combines the climate of the Mediterranean basin with the desert climate. Based on previous scientific studies, the NASA database showed good agreement with the measurement data of global solar radiation based on previous scientific studies. Therefore, the monthly NASA database is utilized to investigate the potential of solar energy in the selected region. Also, in this table list, the electrical device used in the considered family household and villa, like air conditioning, televisions, washing machine, electrical cooker, toaster, and microwave. And also in this figure, we show the monthly electrical energy consumption of the considered household are shown in this figure for choosing house and villa, because we already choose two different locations. The first location is a villa, and the second location a household. As we see in y-axis, there are energy payment kilowatt hour, and we have a data of the electrical bills in x-axis in January, February, and all month in the year from 2011 up to 2020. And also in this paper, we choose a red screen software to calculate our result. And the red screen is a valuable method for research and estimated for renewable energy system stability connected to the grid. And a red screen expert made use of the software to validate the techno-economic grid-connected solar PV system in different regions. And we have a steps of red screen software. The first one, energy model. Second one, cost analysis. Third one, greenhouse gas analysis. Fourth one, financial analysis. And the last one, sensitivity and risk analysis. I'm coming to my result and discussions. Monthly solar radiation. It is well known that performance of PV system modules is influenced to several climate parameters, including meteorological factors of the specific locations. The table showing monthly global solar radiation and average air temperature for the selected location in Amman, Abu Nsair, and Al Jam. Based on the value of solar radiation at the selected location, it is found that the solar resource of the selected location is characterized as excellent class 5. Therefore, the region is a suitable region of installing a PV system in the future due to the high value of global solar radiation. As we see here in this table, we have two selected located, and we have global solar radiation and air temperature, average air temperature, as we see in this table. And we can see here the value of global solar radiation and the value of air temperature, average air temperature to location. Electricity generation and capacity factor. The optimum angles, including slope angle and azimuth angle for the fixed tilt system, are statement using photovoltaic geographical information system simulation tool, PVGIS. Therefore, the slope and azimuth angle for Abu Nsair and Al Jama, it was 28 and 4, and Abu Nsair 28 and 6 respectively. And in this project, we already selected the design power PV system, and we choose two different type of solar cells. The first one, it's a monocrystalline SI CS6 S300M, and the second one, polycrystalline SI silicon CS6X310P, were selected, which are manufactured by Canadian Solar. It's a famous company who's manufactured solar panels. And we selected and choose one inverter. It's used to convert the power from DC to AC and fit directly to the grid for the proposed PV system. And in this table, we can see the specifications of this inverter, like a model and name, manufacturer, and system range, and the maximum and minimum output and efficiency already, and the cost in USD. Performance of the proposed PV system. The performance of the aforementioned sun tracking system is evaluated by the estimation of the economic and environment factors for each system. The financial parameters project life, it's coming to or equal 25 years. Fifth term, 50 years. And electricity export escalation rate, 2%, are considered as input variable for estimated economic indicators, which are assumed based on other previous scientific studies. The main result, reducing the economic performance of the 2 kilowatt and 5 kilowatt grid connected rooftop PV system for all developed PV system are it is noted that the value of LCOE is certain interested by 4% when the two-axis system. And this one, LCOE, it's mean levelized cost of energy. The appointment result demonstrated that the development of the proposed 5 kilowatt PV power system is economically acceptable due to the obtained favorable economic result. And here I'm coming to my conclusion. In this study, the feasibility of a small-scale PV system in different locations in Jordan. This found that the annual energy output showed that the 2 kilowatt and 5 kilowatt grid-connected PV system in the selected locations were within to the range of 3,499.03 up to 4,947.66 kilowatt hourly. And in the second location, 8,581.28 and 12,128.30 kilowatt hour, when fixed tilt and two tracking system have been used respectively. The result that the energy production cost of the proposed system in competitive with the electricity company. After additionally, the difference between the energy production cost from the fixed tilt system and energy production cost from the two-axis tracking system is lower than 4%. It can be concluded that the grid-connected PV system with the two-axis sun tracking was found to be economically justifiable. Furthermore, it is found that 5 kilowatt grid-connected PV system is a more economical option than 2 kilowatt because of the higher values of the net present values and annual life cycles savings and internal rate of return, as well as lower value of, as I told you before, LCOE, it's mean levelized cost of energy. And here I want to thank you for listening, for your attention for me. If anyone have a question, please ask me. And already we have a contact, a third one. If anyone has a question, you can contact me or you can ask me. Thank you so much.
Thank you so much, Adnan Al-Haj Othman, for your presentation. That's a very nice presentation. I think this is the one sources or one umbrella with the research of Sharfi, and also perhaps with the Muhammad Al-Mutba.
Yes.
Okay. Is there any question for Adnan Al-Haj Othman? Yeah, it seems quite difficult to ask because everything is clear and concise.
Thank you so much, sir.
Yes. All right, then, if there's no questions, I would like to call Muhammad Al-Mutba
Is that right?
Assalamu alaikum, sir. Yes, it is
Wow.
Muhammad al-Mujtaba Abdullah.
Alhamdulillah. So your title of presentation is Evaluation of Wind Energy Potential for Different Regions in Lebanon based on NASA Wind Speed Database. Is that right?
Yes.
All right.
Exactly.
Alhamdulillah. So I think Muhammad Al-Mutba, the screen is yours. You can start now.
Okay, sir. Is my presentation is clear?
Yes, it's clear.
Okay. Assalamu alaikum again. Good morning from here. I am Muhammad al-Mujtaba Hamid Ali Abdullah, Mechanical Engineering Department, Nearest University, Nicosia, North Cyprus. Today I will present our paper, Evaluation of Wind Energy Potential for Different Regions in Lebanon, based on NASA Wind Speed Database. My contents, I will talk about introduction of the study, material and method, result and discussion, and conclusion. It will be my end of my presentation. My introduction, I will talk about the energy, of course. The energy sector is the most prominent of the economic crisis and the environmental disaster in developing countries, including Lebanon. In Lebanon, the growth of population, rising living standards, tourism, and industry sector have led to an increase in the energy demand and the increased electricity cost associated with fossil fuel-based electrical energy production. Several scientific researchers have investigated the potential of the wind energy in different locations in Lebanon. For instance, Qasim et al. Investigated the visibility of 100 megawatt grid-connected wind solar system in the Riyadh region in Lebanon. The result indicate wind power is considered more efficient than solar power in the selected region. The aim of this study, in this study, small-scale wind turbines are used to generate electricity from wind. To evaluate the wind energy potential at different locations, we choose some locations like Akkar, Ba'labek, Beirut, Zahla, Ba'bada, Nabtiya, Tripoli, and Sidon in Lebanon. This study goal is to evaluation of wind energy potential for different regions in Lebanon based on NASA Wind Speed Database, using NASA database to find a suitable region for installing wind system in the future. Also, the proposed system can provide valuable inputs for the development of new policies and innovative solutions for the wind market growth in the country. Study area and data. The climate of Lebanon is a Mediterranean climate, cold to moderate and humid in winter and hot and dry in summer. The average temperature is varied from 16 degrees Celsius on the coast or 10 degrees Celsius Becca value to 32 degrees. Also, the average precipitation is within the range of 700 to 1,000 millimeter in coastal area. Also, it is 1,500 to 2,000 millimeter on mountains elevation. In areas of more than 2,000 meters, the rain are mainly snowy and help to maintain a basic stock that feeds about 2,000 springs during the drought. Here is the information for the selected region. As I mentioned before, we choose Akkar, Ba'labek, Beirut, Zahla, Ba'bada, and Nabtiya, Tripoli, Sidon. Here is the latitude and longitude, altitude for all of them. For analyzing the characteristics of wind energy in the selected location, a monthly NASA database is used in the present study. Analyzing the characteristics of wind speed is considered the first step to determine the wind energy potential at given location. As I mentioned before, several scientific studies have studied wind speed characteristics using various distribution functions. The variable distribution function is widely used to study the statistical analysis of wind data. The wind power density indicates how much energy is available in the region that needs for converting it to electricity by using a wind turbine. The amount of generation electricity from the wind turbine is dependent on wind speed. The measurement of wind speed and the power curve of the wind turbine is essential to develop a wind project in a specific region. In this study, the method of maximum likelihood is utilized to determine the variable parameters. In the result and discussion, I will talk about wind energy characteristics at the height of 10 meters. The monthly wind speed NASA database from 1983 to 2020 was utilized to identify the characteristics of wind speed of each selected region using the variable distribution function. During the investigation period, the highest and lowest value of wind speed are recorded in February and August with a value of 4.457 meter per second and 2.665 meter per second, respectively. For the height of 10 meters, it is found that the maximum and minimum mean wind speed are occurred at Tripoli and Beirut and Zahla with a value of 3.565 meter per second and 3.030 meter per second, respectively. And should be noted that the parameter of the variable distribution functions is determined at the height of 30 meter and 50 meter based on wind power classification 10 meter and 30 meter. In this figure, as we see, it is monthly wind speed data for selected region at 10 meter. In the x-axis, it is the months, and it is in y-axis is wind speed meter per second. And as we see, Zahla, it is in the top. This study, the value of air density is assumed to be constant, rho equal 1.20 kilogram meter cube. It is found that the highest value of wind power density is observed in Sidon for all heights. According to the average power density value classification, the wind energy generation potential of all regions is classified as class 1, and it is poor, unfortunately. The high-scale wind turbines are not suitable to generate electricity from wind energy in the selected regions. But when we assessment of wind turbine performance, the result is going to something else. First, the low cut in wind turbine are being considered as one of the most attractive solutions to reduce the electricity crisis and can be installed on the rooftop of the building. In this study, we choose two types of wind turbine: vertical axis wind turbine, WRE 066 kilowatt, and Proven WT6000 horizontal axis wind turbine. In Lebanon, the average household area is varied from 78 meter square to 200 meter square, and the average number of floor buildings is within the range of 2 up to 6 floors. Therefore, it is assumed that the number of the floor in the selected building is 2 floors. The height of the household is about 10 meters, and it is found that the maximum annual energy output is about 4.390 kilowatt obtained from the Proven WT6000 model. In this table, the annual energy output for the selected wind turbine at various heights, we use two types, 10 meter and 30 meter. Here is the parameters, the mean, variance, and our region, Akkar, Baalbek, and Beirut, etc. Also in this figure, it shows us that the annual energy output and capacity produced by wind turbine, and it seems clear proven WT6000 it is the best one for us. Also, we found that the highest energy output is recorded in Sidon and Tripoli with the value of 4.390 kilowatt and 4.395 kilowatt. Besides, it is observed that the maximum monthly capacity factor it is about 73% kilowatt, obtained from the proven WT6000 model and recorded in Sidon and Tripoli. In general, estimating the cost of energy is essential to select the best wind turbine between the different models because, of course, wind turbines is very, very expensive. My conclusion, I will conclude that the main objective was to evaluate the potential of wind energy as a power source for producing electricity. A 33-year NASA database for the selected region in Lebanon has been used in this work. To this aim, the Weibull distribution function was utilized to study the distribution of the wind speed characteristics at different locations in Lebanon. In this work, the result shows that the maximum wind speed of 4.457 meters per second was found in Sidon, and the minimum one was found in Beirut and Zahla with value of 3.695 meters per second. Moreover, the mean value of wind power density were found within the range of 29.995 to 18,001 watt meter square based on the wind power density classification. It is observed that a small scale wind turbine is recommended to be used in the selected regions for generating electricity from wind. Also, as I mentioned before, it is found that proven WT6000 horizontal axis wind turbine had the highest capacity and energy output compared to the vertical axis wind turbine. Thank you so much for your attention and listening. Here is our contact. I am the third one. If anyone has a question, I will be gladly to answer him.
Thank you very much, Hamid Ali Abdallah. Very nice presentation. Also, I see very nice campus there.
Thank you so much. You are welcome always, sir.
That's in the Cyprus, right?
Yes, it is in Cyprus.
That's a small island, I think.
Yeah, it is a small island.
All right, okay. Well, before I make some notes, is there anybody who wants to ask to this presentation? It's very interesting. No? Well, yeah, it's always interesting to talk about sustainability energy. And I'm hoping that three of you, the title of that Sarfi and Adnan Ahaj Otman, and also you, Hamid Abdallah, will conduct the research in Indonesia, yeah?
Of course, sir. This is our field. We are encourage ourselves to go inside and deeply this field.
Yeah, because this is a very interesting things, especially in the developing countries like Indonesia and
and also Africa.
Africa, yes.
Yeah,
and I think
also,
you have already done in Africa as well, yeah?
Yeah, of course.
Okay.
It has been done in some countries in Africa, and also, as you know, the environment, now we need to go on the way that to let us to produce electricity from the clean energy.
All right, yeah. All right then, because there's no one asking question for you. Again, we are positive thinking that, well, your presentation is very nice, very good, very clear and concise. So I think.
Thank you so much, sir.
Yeah. All right. Okay then, thank you very much, Hamid Ali Abdallah, for your presentation. And before we go to the 8 presenters, I would like to call Alexandra Budilovskaya and Yushao if there are presenting here? No. And how about Adel Ahmed, Walid Said, Ahmed Asran, and Ibrahim Nusair? No. Okay. All right. For those who are still in this room, I just remind you to make what we call the attendance list. You can fill out or fill in the attendance list through the link that I shared through the chat room. Yeah. All right, then I will call the 8th presenter is today is Billy Keppel with the body, Fatima Wali, and Trina Talley. So the title of the presentation is Heavy Metal Analysis and Identification of Heavy Metal Resistant Bacteria in Sediments from Manado Bay. I think you are already there, Billy Keppel. Are you there? Yeah. Okay. Your presentation will be 10 minutes only and followed by question and answer for 5 minutes. For Billy Keppel, time is yours now. Thank you.
Okay, thank you. Can I share my presentation?
Please. Yes.
Sorry. Yeah. Can you see my slide?
Yes, it's clearly see.
Okay. Thank
Yes.
you again. Good afternoon, moderator. Good afternoon, everybody. I'm Billy Keppel. I would like to present the study entitled Heavy Metal Analysis and Identification of Heavy Metal Resistant Bacteria in the Sediments from Manado Bay. Yeah. Manado is the capital city of North Celebes in Indonesia. It's a growing city and largest city in the northern part of Celebes Island. It is situated in Manado Bay and is also a center of government and business in northern part of eastern Indonesia. In the last 20 years, the number of people has increased sharply, be much more crowded as more various people's activities The North Sulawesi or North Celebes is a volcano land that is naturally the source of minerals, including heavy metals. There are 4 rivers are from the hill down, passing along the land, cross the city, and finally empties into the Manado Bay. There is a there is a complex interaction amongst the environment and living things in the Sea of Manado Bay. The dynamic interaction is also contributed by the rivers and the Manado people activities. Fishes and other seafoods from Manado Bay are consumed by the Manado people and surroundings. Thus, the people become the peak of the food chain. A consequence of this condition is for some minerals, including some heavy metals, are exposed to the people. The characteristic of the heavy metals such as arsenic, cadmium, chromium, mercury, and lead are toxic or exceed in the allowable threshold, persistence, and bioaccumulated. One negative impact of the heavy metals is degradation of microbial population. However, there are often certain types of microbes that are resistant or tolerant of the presence of heavy metals. Several microbes have developed efficient systems for heavy metal detoxification. Thus, the bacteria become heavy metal resistant bacteria. There are several bacteria have been found from aquatic environment that resistant to heavy metals. In this presentation, we can see some heavy metal resistant bacteria, Bacillus species, Gamella species, Pseudomonas aeruginosa, and Proteus mirabilis, Stenorophonas, and Pseudomonas species. Okay, the sediment samples. The aims of the aims of this study is to analyze heavy metals and heavy metal resistant bacteria, the sediments in the Manado Bay. The sediment samples from 5 sites or estuaries of Tondano River, Sario River, Talawan River, Bahu River, and Kando Hospital Waste, which pass through the Manado city, were each taken at 3 points with a depth of 10 centimeters from sediment surface. The samples were collected and sent to the laboratory. The determination of levels of heavy metal or arsenic, cadmium, chromium, and lead using ICoGEE analysis techniques, and determination of mercury levels we using analysis CVAFS analysis technique. Okay, for the isolation and quantification of metal tolerant bacteria, each sample was added to nutrient broth, which contain one of these following substance that contain chromium, arsenic, lead, and mercury with concentration, various concentration, 25, 40, 100, 200, 300, and 400 milligrams per liter, then incubated at 37 centigrade degree for 24 hours. It also examined by using morphological, physiological, and biochemical tests, and the genetically identification by using 16S RNA gain identification. Okay, I would like to show you the site of sample collection. This is the map of Indonesia in the white background, and we can see the red rectangle. And when we zoom larger, you can see the eastern part of northern Indonesia, where the North Sulawesi province and the Manado city. So the red spot is the Manado city that's situated in Manado Bay. There are 4 location sample collection as I mentioned before, the 5 locations spread out along the coast. Okay, now we move to the result and discussion. You can see from the table, and I showed the tabular and graphical presentation about the concentration of the heavy metal in the five sites. And we can see the last column, the average of the heavy metal, the arsenic, cadmium, chromium, mercury, and lead. So the arsenic concentration within the standard limit in average 0.684 milligrams per liter. Actually, it's less than 1 milligram per liter. That is suitable for the regulation according to government regulation number 82 in year 2001 concerning water quality management and water pollution control. The arsenic level still met the government regulation. Even though when we see the studies conducted by Lasut and Mabuat in previous years, it's much less concentrated compared to our studies here. It only 0.0012 ppm and 0.0002 ppm respectively. So arsenic form in aquatic environment is 2 forms, pentavalent arsenide and trivalent arsenide. The uptake of sediment depends on the form of the arsenic. Microbial activity forms arsenic into gaseous methyl arsenic and enter to the atmosphere. The arsenic, it will be carcinogenic compound and cannot be seen immediately. The most likely action is to prevent the concentration of arsenic in the sea. Okay, this is about the cadmium analysis. Cadmium concentration at the 5 locations range from 1.68 to 2.06 milligram per liter. So it exceeds the threshold of set in government regulation. Actually it should be less than 0.01 milligrams per liter. It is unique in cadmium characteristic that is help brain development in the children, but in adult human, it can bring negative impact, which can increase the risk of breast, cardiovascular, lung, and heart cancer. Other effects include kidney failure, rheumatism, arthritis, and bone damage. Cadmium can undergo biotransformation and bioaccumulation in living organism and will accumulate in human body. Can only leave the body after 20 to 30 years later. This is about chromium analysis. The chromium concentration range from 3.6 up to 8.4 milligrams per liter. So it exceeds the threshold set in government regulation. It should be less than 0.05 milligrams per liter. Chromium in water, it is natural source, is very small amount. In human activities, in large number due to industrial activities, household waste, and other activities through waste that enters the water body. Okay, about the mercury analysis, the concentration of mercury is range from 0.02 until 0.13 milligrams per liter. So all samples in the 5 sites exceeds the threshold set in the government regulation. So the highest concentration is okay, thank you. The highest concentration is the sample from location is the sewerage in the hospital, the general hospital in Manado, the biggest hospital. Mercury in the biosphere will accumulate in the environment, poisoning human and animals, will affect in physiological disorder, nervous system, growth disorder, and kidney disorder. Actually, there are some bacteria in human that resistant to mercury. And the last is lead analysis. The lead concentration at 5 sites range from 7.8 to 14.3 milligrams per liter. So it exceeds the allowable threshold. And this is the biochemical identification of the bacteria from 10 isolates. This is the identification based on the genetic identification. We have 10 bacteria that resistant to the heavy metals. And I will conclude that the water bodies have been subjected to heavy metal pollution, natural and anthropogenic activity in urban environment. The sediments obtained from Manado Bay are contaminated with heavy metals, especially cadmium, chromium, mercury, and lead. The bacteria that are resistant to these heavy metals, namely Bacillus cereus, Pseudomonas aeruginosa, Staphylococcus aureata, Acinetobacter species, Brevibacterium species. So the 5 species in bacteria have the potential to be used for detoxification of heavy metals in the environment. So it is recommended that the heavy metal concentration from the sediments should be monitored periodically and could also be monitored periodically to the seafood and to the people. Okay, I think that's all. Thank you.
All right, thank you very much, Billy Kepo. My question is Manado Bay including Bunaken or not?
Yes, Bunaken is not only by a small boat is only 1 hour from the small seaport in Manado.
All right, so it's only 5 years the heavy metals become developed, yeah, in there.
Especially the cadmium.
The cadmium, yeah.
No.
All right, that's very interesting, and we have to make a solution about that matter, yeah. Well, okay. Is there anybody who wants to ask to Billy Kepo? Yes. Okay, I think there's no question for you because it's quite a very nice presentation and clear already. And yeah, I'm sad because of the problems there become developed with the heavy metal. I'm sorry about that, and hopefully we can have the solution for decreasing the number of heavy metals there. Yeah, okay, Pak Billy, thank you very much for your presentation, and we wait until finish our presentation, and then there's some information before we leave this room. Thank you very much, Billy. Okay, the next presenter will be Tan Tran, Hong Li, Tian, and Tan Lam Phan. With the title of presentation is Application of the Anaerobic Co-Digestion Method to Sewage Sludge Treatment toward recover green energy and utilize nutrients for agriculture. Are you there, Tan Tran? Ya, tapi dia di 82. No? Okay. We go to the 10th presenter. Call Min Tran Tant, Tin Nguyen Hu, Kiang Lam Van, Lok Hu Ho, Hien Pho Thi Diu, and Tan Tran. With the title of presentation is Green Technologies for Air Pollution Treatment by Microalgae in Tubular Photobioreactor.
Yes.
All right. So
Yeah.
that's your friend's not coming, yeah?
Yeah. Let me introduce a little bit about myself. My name is Min, and I come from Vietnam, Ho Chi Minh City of Technology University, and I will represent it research. So now I would like to share my screen first. Okay, can you see my screen and hear me well?
Not yet. Please try again.
Yeah. Screen. Okay.
Okay,
and now can you see my screen?
yes, it's clearly see. Go ahead.
Okay. Hello, everyone. I would like to start a presentation of our research. The topic named Green Technologies for Air Pollution Treatment by Microalgae in a Tubular Photobioreactor model. And this study consists of 4 parts. Firstly, introduction, secondly, materials and research methods, thirdly, results and discussion, and finally, conclusion. It's evident that under the continuous development of society, we have generated a lot of waste into the environment, especially in the atmosphere. And then numerous problems also come from here, such as climate change and environmental pollution, and which severely affect on humans and creatures. Therefore, we have even more reason to care about the environment, and carbon dioxide representative of those problems. And according to recent reports, the amount of CO2 is still increasing. And right now, the CO2 has reached approximately 415 ppm, so that would cause a lot of problem for us. These CO2 sources come from a variety of activities, and up to 70% of them come from burning fossil fuels. In general, the current and future trends still how to reduce the amount of CO2 in this atmosphere. Many solutions have been studied to solve that problem, such as using clean energy, low emission technology, and especially is the application of microalgae. According to many studies, microalgae is a photosynthetic organism. They have ability to convert CO2 to grow through the reaction mechanism of CO2 in water, and thereby indirectly reduce the amount of CO2. In addition, the biomass from algae can be used as a biofuel, and also microalgae have a very fast growth rate. And photobioreactor technology is a system that uses light source to culture microorganisms. In this system, specific conditions are carefully controlled. Therefore, the photobioreactor or tubular photobioreactor system offers a high culture efficiency. Based on the characteristics of microalgae and the tubular photobioreactor technology, this study aims to build a simple algae culture system in order to treat the CO2 emissions. Next is material and research methods. We use the algae called Chorella vulgaris, which were provided from the Environmental Technology Laboratory at Nguyễn Tất Thành University, Ho Chi Minh City in Vietnam. And this microalgae will be grown and propagated in laboratory with cool medium. And when the concentration of microalgae is 10 million cells per milliliter, it will be used for algae culture experiments. About the inlet gas source, the two-stroke 50 cc mini motorcycle engines is the source of emissions with the parameter shown in table 1, and the fuel is a mixture of gasoline and gas with a ratio of 51 With the scale of the tubular photobioreactor model built in the laboratory, the experiments were conducted with the aeration time of 30 min per day and the flow rate is 5 liter per minute. On exhaust gas from the engine will be stable in the soft spots and to use for experiments. We pay much attention to the CO2 concentration in the exhaust gas with a concentration of about 1700 to 1900 ppm. We will use the sensor to continuously measure the input and output emissions, so we will get the treatment efficiency. This is the image. This is a picture of the system sketch in this study. The components of the system are shown in the slide on the slide. In addition, for easy transport, we installed this system in a box-shaped iron frame with wheels. At the same time, we equipped 2 light bulbs to provide light energy for micro LG. The system will be adjusted based on the relevant environmental factors so as to provide a good condition for LG growth. And these are the design and operating parameters of the model. Third is the results and discussions. This is the image of the model in reality after assembled through the parameter that we have presented. And then I did the research experiment. Coming to the test result section 1, the ability to grow microalgae under natural gas conditions. In general, with the first experiment, the microalgae growth was quite stable during 26 days and reached 4.5 million cells per milliliter. And besides the color image of the microalgae in the reality over time, move on to experiment 2, the growth and adaptability of microalgae in exhaust gas conditions. After the experiment, the concentration of the algae biomass grew at a stable rate and reached 6 million cells per milliliters. In general, during this period, the concentration of algae biomass increased but not significantly. A possible reason is because the model has gradually stabilized and the number of new cells is almost equal to the number of dead cells. Through this experiment, we found that under the new condition of exhaust gas in this model, the microalgae can survive and not only develop stable, but also tend to increase. For the CO2 removal experiment, the results showed that the ability of microalgae to absorb CO2 after 11 days is quite good. The highest processing efficiency was 35.9%, and the average efficiency of the whole experiment was 26.59%. We can see that with a decrease in CO2 concentration, the algae in the system also increased. With these results, if we compare with some previous studies on CO2 absorption efficiency, this result of the system is not really good. The low efficiency may be due to the influence of other gases components such as dust, dioxide, sulfur dioxide. In addition, the operating parameter of the culture system such as aeration rate, pH, light, and temperature have not been adjusted to the optimal level. However, the potential for improvement of this system is still wide open. Finally, in conclusion, overall, the design model in the form of tubular photobioreactor combined with microalgae development to treat exhaust gas has shown the ability to provide a stable environment for the microalgae Tornella vulgaris and significantly reduce the pollution of the exhaust gas. Initial results are quite impressive, although the result needs to be improved and more experiments to do, but the benefits for the environment and people are very promising. I think so. And that's the end of the presentation. Thank you very much for watching. Thank you, all of you.
Well, thank you very much, Trantan, for
Yeah.
your presentation. It's a very interesting one. The green technologies. Is there anyone to ask Trantan about his presentation? Trantan, this is your ideas, or the ideas is already there, and then you just copy to in your area, or this is your real your idea?
This problem technology, example of photobioreactor is already have in the world, but in my country, in Vietnam, this system uh, is not already. So I want to apply this system to my country to treat emissions. I think so.
Okay, so what is the difference between your ideas or you are research in your country with the other country? Is there any difference?
So I think in my country, because you know, in Vietnam, Ho Chi Minh City, especially the air pollution is really extremely. So in my country, there are a lot of motorbike around here in the city. So when you so because I think the air pollution, is really extremely. So I want to apply some technology, biotechnology, to solve this problem.
Yeah. Okay, this is a very good idea, and hopefully in Vietnam the microalgae will help to decreasing the air pollution in the Ho Chi Minh,
Ho Chi Minh City.
Ho Chi Minh. All right. Okay, thank you very much, Tantan.
Thank you very much.
I will ask you: is your friend are present today? Trantan?
No.
Ah, all right. Okay. Okay. All right. Thank you very much.
Thank you very much.
Well, if there's no the friend of Tantan, we still have one left presenter. That is Atin Nuryadin and Suyoshi Imai, with the title of the presentation is Phosphorus Desorption and Recovery from Aqueous Solution Using Amorphous Zirconium Hydroxide Layered Double Hydroxide Composite. Yes, Pak Atin Nuryadin is already there. I think, yes, you will presenting your presentation in 10 minutes and continue with the 5 minutes question and answer session.
Yes.
For Pak Atin Nuryadin, the screen is yours.
Yes, thank you very much. Good afternoon, everybody. I am Atin Nuryadin. I am from Indonesia, but now studying in Yamaguchi University in Japan. Today, I would like to present my study about phosphorus desorption and recovery from aqueous solution using amorphous zirconium hydroxide, magnesium iron layered double hydroxide composite. As we know that excessive discharge of phosphorus into water bodies often causes serious eutrophication problems, which leads to algal blooms and the disruption of aquatic ecosystems. There are many freshwater systems in the world that are dealing with eutrophication problems. Then, as global phosphorus fertilizer consumption is increasing, phosphorus production is forecasted to increase and reaches its peak in 2033 and decreases as phosphorus rock is a non-renewable resource. Therefore, by considering global eutrophication problems and phosphorus scarcity, it is essential to deal with not only phosphorus removal, but also phosphorus recovery and reuse. Chemical precipitation of phosphorus to calcium phosphate has become an attractive method for phosphorus recovery because calcium phosphate has been found to be effective for agricultural fertilizer. However, the coexistence of other metal ions such as magnesium and zinc interferes with the calcium phosphate precipitation. So these ion should be removed before the precipitation process. And adsorption has become a fascinating method for phosphate separation from water because of its advantages as listed here. Especially, it has high selective phosphate adsorption, which eliminates interfering ions and subsequently increases the effectiveness of phosphorus recovery. From our previous studies, a series of bed and column experiments showed that adsorption capacity of composite here was higher than LD8 or amorphous zirconium hydroxide individually. Moreover, it has good removal efficiency retainment over 8 regeneration cycles. However, this feasibility of regeneration was only investigated technically. Therefore, it is important to further investigate the economic feasibility of the composite reusability and phosphate recovery possibility. And the objectives of this presentation are to analyze the cost effectiveness of composite synthesis as phosphate adsorbent, then to investigate the suitability of sodium hydroxide as desorption agent through adsorption mechanism analysis, then to examine an alternative desorption agent to decrease the cost of adsorbent reuse, then to evaluate the recovery of phosphorus from desorption solution obtained from the composite regeneration. And for the experimental of this study, desorption experiment was carried out after adsorption experiment by reuse to normal sodium hydroxide solution with these experimental conditions. And then supernatant was collected for phosphate concentration determination. And for the reusability experiment of the composite, it was carried out through a 7-cycle adsorption-desorption cycles. Then for the recovery experiment, we use calcium chloride to precipitate out calcium phosphate with different calcium to iron molar ratio and different pH. And then the residual phosphorus was determined, then the precipitation product was analyzed by XRD analysis. And this figure shows the comparative cost for the removal of 1 milligram P of phosphate using studied adsorbents. As we can see here from the figure, that the uncalcite composite was found to be effective in reducing cost of phosphate removal. It reduced about 25% of cost uncalcite LD8 application, and then reduced about 40% cost of uncalcite amorphous zirconium hydroxide application. And this result implies that the cost of zirconium and LD8 usage for phosphate adsorbent could be reduced by composite synthesis. Then from our previous study, the anion exchange in the LD8 interlayers was one of the adsorption mechanism of phosphate into the composite. However, based on this XRD pattern analysis of composite before and after adsorption, it showed that anion exchange was not the main mechanism of phosphate adsorption. This implies that desorption was better performed by releasing phosphate adsorbed via surface adsorption rather than exchange the intercalated phosphates in the LD8 interlayers. And this is the analysis of the number of effective reusability cycle by 1 normal sodium hydroxide solution. And it was calculated from our previous study result. And the analysis showed that the reusability cycle by 1 normal sodium hydroxide solution was only effective for about 1 cycle in reducing cost of new adsorbent synthesis with 5% of performance decline. Therefore, we also investigated an alternative method for economical desorption by reuse to normal sodium hydroxide solution. And this figure shows that during 8 cycles, the composite regenerated by reuse to normal sodium hydroxide solution could maintain a higher adsorption ability than composite regenerated by 1 normal sodium hydroxide solution. Moreover, the chemical cost for desorption by reuse to normal sodium hydroxide solution during 8 cycles cost about 4 times lower than the chemical cost of 8 times new adsorbent synthesis, emphasizing that the reused normal sodium hydroxide solution is an alternative economical reagent for the composite regeneration. And this figure shows the XRD patterns of 8-cycle adsorption-desorption composite. As we can see from the figure, that the composite structure, as we can see the peaks of the fresh composite, was still preserved even after 8-cycle adsorption-desorption process, emphasizing the chemical stability of the composite in alkaline conditions. And this results of the post-porous recovery, as we can see here, that the calcium to phosphorus molar ratio of about 3.5 and pH of about pH about 13 had the highest precipitation percentage for phosphate precipitation to calcium phosphate. And this figure shows the XRD patterns of the precipitation product. As we can see here, from the analysis of these XRD patterns, the formed precipitate under the experimental condition in this study was hydroxyapatite. And hydroxyapatite was found to be effective for agricultural fertilizer. And these are the conclusions of this presentation. First, the cost associated with the uncalcined composite in removing phosphate from water was found to be less than those of amorphous zirconium hydroxide and LDH individually. Second, the desorption of adsorbed phosphate on the composite surface by sodium hydroxide solution was found to be an appropriate method for the composite regeneration, since most phosphates are adsorbed by surface adsorption. Third, the application of reused normal sodium hydroxide solution during 8 cycles cost about 4 times lower than the 8-time synthesis of the new composite and maintained a higher adsorption ability than regenerated composite by 1 normal sodium hydroxide. And fourth, the dissolved phosphate from the composite was successfully recovered as hydroxyapatite, where optimum phosphate recovery was obtained by adding calcium chloride at pH 13 and calcium to phosphorus molar ratio of about 3.5. And these are the references of this presentation. That's all. Thank you very much for your kind attention.
Thank you very much, Pak Atin Nuryadin. That's a wonderful presentation. I like your presentation style and also the material. It's very clear and concise. Okay, is there anybody who wants to ask Atin Nuryadin? Well. As usual, there's no question because I think, yeah, just like what the previous presenter said, everything is concise, clear, and then it's hard to us to find what to ask, something like that. And thank you very much for your presentation.
Yes, thank you very much.
Yeah, and now I think we have at the end of the session. Ladies and gentlemen, this is the end of this parallel session. On behalf of the committee, we would like to show our gratitude, your active participation to this conference. We do hope that this event gives us fruitful insight for the development of future science. To kindly remind you, presenters and participants are expected to join for tomorrow's schedule at 10:45 Indonesian time, yeah? 10:45 in Indonesian time on the closing ceremony of ICoGEE. There will be the announcement for the best presenter for every parallel class. Thank you for today, and we do apologize for the inconvenience during this parallel session. And see you tomorrow on the second day of ICoGEE. Good afternoon and have a nice day. Thank you very much. Bye-bye.
Thank you, sir. Have a
Thank you
nice
very
day.
much.
Bye.
Thank you, sir.
Bye.
Thank you, sir.
Bye. Pijit malam ini. Ini recording di stop aja ya. Recording. Oh jadi kok saya live nggak apa-apa di live nih. Nah makanya saya nggak berani nih kalau belum. Dari? Jadi stop recording ya. Nah,